Okay, so now in chapter 3, we have done looking at the triple integral where we need to use a Cartesian and also the cylindrical coordinate. Okay, where we know, as we know that the basic of the cylindrical coordinate is from a cylinder, where that one is the extension from the polar coordinate system on double integral. Okay, now we want to look another coordinate system that that we can see in triple integral, where it is based on the sphere, where the name is given by spherical coordinates. The basic of the spherical coordinate is coming from the cylinder, sphere. Okay, so okay, now when we are talking about the sphere, so when we draw a sphere, okay, let's say with with radius 1, so that is 1. This is -1, this is -1. So there are, when we do the traces, so there are the combination of the circles for every plane. Okay, so here we have this one, and on the xy plane we have this one. Okay, so this is a sphere with radius rho, with radius 1. Okay, so sometimes instead we have a complete sphere, we can also hemisphere, just half of the complete sphere, right? So when we have that, so we just like a ball, but it is part of the sphere. Okay, we've made this one. Okay, and instead of we have a hemisphere, we can also the combination. If you look at the sphere here, so inside the sphere we can imagine there can be another surface where depends on the, let's say, okay, so let's say that is your surface. I mean, inside the sphere there is we can assume there is another surface or surfaces. So what is this? Can you see that? So if I highlight this one, what is that? It is a cone, right? It is a cone. Not the whole here is cone. So down here, the bottom one here is a cone, and the top one here is part of the sphere. So the combination of the cone and the sphere also can be part of the hemisphere. But it depends on the size of the cone, depends on the angle that you have. What I mean by the angle here, so I cannot increase that one. So depends on the size of the angle of this one. So that one is called phi. Okay, so I will explain more further about the ice cream cone like surface, where this one is the standard surface belongs to the spherical coordinate, as you can see from the lecture note. So you can see here it is a cone, the ice cream cone, and the top here, the ice cream here is part of the sphere. Okay, so actually inside this sphere you can have a many cones with different sizes, which means that you can have a larger cone where there is there is also your cone covered by, so the top here is part of the sphere. And also you can have infinitely many cones there. So this is also part of the cone with a larger size, larger angle. So there is a cone and covered by this one. Okay, but now because of the angle becomes larger and larger, so it looks like almost the hemisphere. And in fact, you can okay, maybe some of you might wonder, is that only this particular size, which means that if I increase the size, so it looks like you have the hemisphere. Is that the largest solid that we can have? No, actually you can increase the size. You can increase the size, so you can have that one. Yeah, I should. So that is the largest size of phi, where your phi here is more than 45 degrees, isn't it? So that is your phi, can be more than 45 degrees. So how does your solid looks like? So your solid is looks like this. So bear in mind, this one is in 3D. So it looks like 2D because this one is our vision from when you are staying here, right? But actually, this one is 3D. Okay, where you can see that they are all part of the sphere with different sizes of phi. Okay, so now the solid that we will have on this specific coordinate system is basically like this one. So it depends on the size of phi. Okay, what else in the variable that we want we will have in the spherical coordinate? Okay, so I just refresh. So in Cartesian, okay, for Cartesian coordinate system, we have x, we have y, and we have z, right? And we have dv. Okay, and for cylindrical coordinate, where this one is the extension from the polar, you have r, you have theta. See, that is 2D, right? That is 2D. I mean double integral r theta. And for triple integral, you have z, and your dv is r dz dr d theta. Okay, so for spherical coordinate here, if you look at from the slide, so you have another variables where you never seen that in the cylindrical and Cartesian, where you have the rho and you have the phi and you have the theta. Okay, so the similar thing as in the cylindrical, you have seen this theta, right? So the way you explain the physical meaning of the theta is similar as in polar, where we know that the theta is the angle on xy plane, yx, and then theta is basically coming from part of the circle, where the theta is the angle starting at x-axis per the theta here is the angle, where how can you determine the angle? So it's starting at the x-axis positive. So if you have this line, so this line is basically then put the arrow, just a line. So depend on the theta equal to, maybe you have 60 degree and so on. So as we know that the range of the theta is lying between 0 to 2 pi, or 0 to 360 degree. Okay, and now I want to introduce you what is the rho and phi. Okay, rho here is the just like r, but r is on 2D on xy plane. R is the radius of circle, so rho is the radius of sphere. So let's say based on the my sketching here, so we know that because we can see from the sketching we have the circle centered at the origin and the radius is 1, so we know that for this the rho is 1. Okay, and what is phi? Okay, so I'm sure that phi, this is very new for you. So the phi, as I mentioned before, it is also an angle, but the way you represent physically about the phi is different. It's not the same as theta. Theta is the angle on XY plane. Okay, so I will show you that using a diagram. Okay, so here, as you can see here, this is XYZ 3D. So where is the theta? So your theta here, as you can see, it is lying on XY plane. And it is an angle starting at axis positive. And then rho is actually, if you, so as I mentioned before, rho is a radius of sphere, where when you have a sphere, so let me sketch the sphere first. Okay, so with radius rho, I put rho and I put rho here. So where is the P here? P here is I just choose the random point on the surface of the ball or the sphere with radius rho. So let's say I just pick randomly. So that is the point where it is on exactly lying on the surface of the ball. And this is the point. So this is the point P at the rho phi theta. So where is the rho? Rho is the length starting at the origin and passing through the point P. As you can see here, rho is the length, or we can say this is the radius of the sphere. Okay, so now you know now the rho, the phi. Rho is the length, theta is the angle, and phi. How can you read phi? Okay, so based on my sketching here about the cone, I already show you many cones here, right? So the size of the cone depends on the phi. So the way I want to explain about the phi, it is an angle, just like you imagine now in front of you there is an umbrella. Okay, an umbrella. So I sketch the umbrella on the XYZ. So where is the umbrella? So my umbrella. So this is the umbrella stick. Okay, so that is the stick of the umbrella. And then imagine your umbrella when it is closed. So it is the closed umbrella, right? Closed. You didn't open it yet. Then when you want to use that, you will open up, right? So I just sketch the umbrella upside down, where the stick is at the top. Okay, and then when you open it, so when you open the umbrella, so how does it look like? So your umbrella becomes, so it is open like this, right? And this is your umbrella. So you open it a bit not so wide, okay, and then when you want to use it, so it becomes wider and wider, right? Okay, and until sometimes then it's become wider and wider. So the size of the umbrella when you open it slowly, so depends on the angle. So what is the angle here? So the angle here, let's say, so the way you want to read the angle, it should be starting from the z-axis positive. Okay, so if you open it just 30 degree, so because this one is in 3D view, so we don't only, when you open it 30 degree for this size, so you are not open on this side only. Actually, you open this side as well about 30 degree at the same time. So we don't total up the total size of the angle. So now when we say what is the angle of this particular umbrella, so only 30, because we we just assuming that this one is open it like this around the Z. So we just open 30 degree. Just like Z is a stick, or in Malay we just say that Z is a tiang, yeah? And when you open it 30 degree, so meaning that this one also 30 degree. So you have this particular size of umbrella, which is if you imagine, or if you relate the umbrella with the cone, so this is actually your cone. The size of when you open the size of the cone, or when you open the umbrella. So when you have the larger cone or larger umbrella, the size of when you open the umbrella, so let's say now your size becomes so it looks like more than 45, right? So maybe this one is 70, I don't know, maybe 70 or maybe 50. So I just put 50. So that is 50. Sorry, it's not so clear. So maybe the size has now become 50 degree. So when you open this side is 50 degree, so the other side also 50 degree at the same time. Okay, so this side also 50 degree. So you have a larger cone. You have a larger cone. Where the phi is 50 degree. Now you have a larger cone. So your larger cone now becomes maybe this one 70 or maybe 80. So maybe 80, I just put 80. Okay, so this one also 80 degree. So now maybe you might want to know what is the range of the phi. So for your information, the range of the phi is between 0. So what is 0? So 0 is when you don't open up the umbrella. It just says that as is positive here. So that is phi equal to 0. So when you have a phi equal to 45 degree, you have a cone, right? You have the cone, and you have phi equal to maybe you have a complete. I mean, maybe you might have this size of phi. So when you have this size of phi, so this side also along. I mean, the size also the same. So what is the size of this one? So this one, your phi is, what is your phi? What is your phi? So it is 90 degree or pi over 2. So this one also 90 degree. So if you have this one, so you don't have the cone anymore, but you have hemisphere. You have the hemisphere. Okay. So now the phi also can be 90. So can we have more than 90? Of course you can, as I draw it here. So when your phi is greater than 90, so let's say you have 135. So you have that particular shape of solid. So it looks like what is the highest phi can be. So when you increase the phi, so we have this version, right? You have this one, we have this. When you have, that is maybe the size of the phi is maybe 170 maybe, and is that the phi can be more than that, more than 170? Of course you can, until the phi is here. So what I draw it here is now your phi is this one and also this one. So for that particular phi, so it happened when phi is equal to pi or 180. So when this side is open up to be 180, so this one also phi is pi, which is 180. So if you have pi equal to 180, meaning that you have a complete sphere. So what we can say here, what is the range of phi? So the range of phi is between 0 and pi. Okay, so you have to take note on this. For theta, for theta, so the range is 0 to pi. But for phi, it is 0 to pi. Okay, so hopefully you're clear with that. Okay, so now how can we have the relationship between the rho, the phi, the theta, and the r, and also x and y? So based on the notes here, so you have some formulas how can you convert from the polar to spherical, from the Cartesian to spherical, or from the polar to Cartesian. So you have to memorize this one. So actually they are all given. They are all given in the list of formula. So you have to memorize this. You have to know how to use them. Okay, because sometimes they will give you all the information in Cartesian or in cylindrical, then they ask you to solve the triple integral using spherical coordinates. So you have to know the formula here. Okay, so you look at this one. If x squared plus y squared is r squared, so that is the formula, the basic formula of the circle on 2D. So now we put another variable z. So we have this one. So as we know, this is the general equation when the sphere centered at the origin with the radius rho. Okay, so we have this to be a sphere and this one is a circle. Okay, you have to take note on that. Okay, so how can we have z equal to rho cos phi, and how can we know that r equal to rho sin phi? Actually, this from this triangle. So can you see that triangle? So if I re-sketch the triangle, so we have a right triangular shape. So this one is 90 degree, and we have the r here, and we have the z here. And where is the phi? So the phi is the angle. Okay, but then the theta is not part of the triangle because the theta here is on 2D, but this triangle is on 3D. Okay, to division. Okay, so now, so if that is the phi, and this will be phi. Okay, so how can you know the length of the z and the length of the r? So from the right triangular shape here, as we know that your phi is over here, so the size of r should be, so where is your rho? So from this triangle, your rho is over here. Okay, that length of the right triangular shape. So if you have all the phi and the rho and the z, so how can we evaluate the r? So r is rho sin phi. Okay, so this is from the basic triangle shape that you have learned during your school time. Okay, and then how about z? Z rho cos phi. So that's why we have this equation, this and this. Okay, so then how can you have from x to be this particular equation? So you replace the r here. As we know that in polar or in cylindrical, x equal to r cos. So you replace the r here. So you replace the r here, okay, this one, by this equation. So you have this. And now for y, r replaced by the rho sin phi. And z, I have shown you this one, right? Okay, so and what I want to say, yeah, you have to take note on this. You have to memorize. You have to know how to use them. Okay, about the dv. Okay, for cylindrical we have dv for cylindrical is r dz dr d theta. That is in cylindrical. Okay, but in spherical it is a bit longer. So the dv is given by, of course, you must have the d rho, d phi, d theta, because that is the three variables in the spherical coordinate, rho, phi, theta. So this is the standard order, but you have to put something here. Just like r, it is just r, but for spherical it is a bit longer. Okay, what is that? So you have to put rho square sin phi. You have to put rho square sin phi. Okay, so meaning that for dv, the order of integration for spherical, it is a bit longer. So every time you want to put the dv, you must consider this one as well. Rho squared sin phi, and the order is normally in standard form, we have rho, phi, and theta. Okay, so now the triple integral in spherical, it is a bit longer because your dv is now you have to add on rho squared sine phi. Okay, so we will look at some example on the next video.